Okay, so here we have the schematic for our low dropout regulator. As you can see, the top one over here is to convert 12 volts to 10 volts, and the bottom one here converts 6 volts to 5 volts output. And in the middle over here, you can see we have the op amp. What the op amp does, it's feedback control. This is to keep the output voltage at a very constant value. And over here, you can see there's the Zener diode over here. This Zener diode is in a reverse bias configuration. What this does is it maintains a constant voltage to the inverting input of the op amp. And on the top here, you can see that we use the PNP bipolar transistor, and hence the feedback has to be fed through to the non-inverting input. This is to ensure the correct feedback, negative feedback control. And on the right over here, there is the variable resistor. We have connected the center tap to the non-inverting input. And by adjusting this variable resistor, we can get the whatever voltage ratio we want, and hence we can control the output. And on the right here, we have two capacitors. This is mainly just for stability. So here's the prototype for our voltage regulator. You can see that we have two inputs. One is a 12 volt input and the other one is a 6 volt input. The 12 volt over here is connected to both the op amps as the power supply for the op amp. And the 6 volt over here is connected to the input of the 6 to 5 volt voltage regulator. And the 12 volt is also connected to the input of the 12 to 10 volt linear regulator. And over here we have the output, and you can tune the output voltage using this variable resistor. And these are just the heat sinks for the transistor. So now we'll be testing out the 6 to 5 volt regulator. So as you can see, this multimeter is currently connected to the output of it, and it's reading 2.7 volts, which is not what we want. So by tuning this variable resistor, we can get it up to 5 volts. Okay. Yep, the output is about 5 volts now. And how to ensure that this is working properly? We have a 1 kilo ohm resistor as well as a 120 ohm resistor. So if this is working properly as a linear voltage regulator, by connecting this resistor, the voltage should not drop, which I will demonstrate now. Yep, so this is the 1 kilo ohm resistor. As you can see, it's still currently reading 5.06 volts, which is no difference. And now for the ultimate test, we connect the 120 ohm resistor. You can see that it's still reading 5.06 volts. Okay, so now we'll be testing the 12 to 10 volt regulator. So you can see the output is currently set to 10 volts. And the same thing, we'll test to see if it's working correctly. We have the 1 kilo ohm resistor. Now to connect it to the output. As you can see, there's no change in voltage. Same thing we'll do for the 120 ohm resistor. Same thing, no drop in voltage. Okay, so besides this strip board, we actually made a PCB version of this. Okay, so here we're going to test the PCB version of our voltage regulator. As you can see, there's a 1 kilo ohm resistor connected now and the output. And you can see it's currently reading 10 volts. And now we'll change it to the 120 ohm resistor. Gives us the same 10 volts. Okay, so here we are doing the measuring test. We are trying to find out what the efficiency of our device is. And over here you can see we use our strip board model. We are doing the 12 to 10 volt converter. And we have the power supply here, and the load is the 120 ohm resistor, which is over here. And here you can see our input is almost 12 volts. The current for the input is 89 milliamperes, and the current for the output is 87 milliamperes, as well as the voltage output is 10 volts. So this is exactly what we want. And if we click analyze, we can see that our efficiency is actually 81.33%. The theoretical efficiency is 83.33333%, and hence our efficiency is quite near the efficiency that we're looking for.